viewers. Every time you turn up, I'm having a cup of tea. You must smell the kettle, that's all I can say. Anyway, what are we up to today, I hear you ask? Well, that's a good question. But in order to answer that, we need an introduction to that. Well, here it is. This is my newly acquired Warco A2F milling machine that I got from a very nice fella over in Romford. And having done a few bits and pieces on it, I must say it's a brilliant little machine. It's a small machine that feels like a big machine. It cuts lovely, the finish is great, but therein lies the rub, is that it is a little machine, and as you can see, the table travel is all the way down. I've got a swivel vise with a chuck, and literally I've got just over 3 inches of space to work in, and it really isn't enough. So it's a good excuse for a project, so we're going to make a riser block to go in the head, say 3 inches, just to bring that head up a little bit further. So yeah, that's what we're going to be getting up to. Just thought you might like to come along for the ride, as they say. So we shall have a go and see where we get on. In the meantime, from Warco and myself, happy watching. Well, we've got the mill back together, so that's good. Got the head back on it. We've made our drawings, and hopefully, if everything goes according to plan, it should fit. So, on with the manufacturing. Right, well here we go with the drawings. You'll have to forgive the crudeness of them, but I'm sure you'll get the idea. So we've got a top plate. That's what we're going to make. It's a top plate and a bottom plate. The top plate will need to have 115mm hole bored into it. That allows the head, the current head, to sit down into that, which it would do on the body of the machine. The bottom plate will have to have a register on the bottom to sit in the hole that's in the base at the moment, again at 115. And then what we shall do is we shall drill and tap 3 holes, M12 by 175. And insert some studs with a lock nut on the back, which we can access through the top hole. That will allow us to bolt the head on, and then we shall recreate the scallop details in the base, which is in the casting already. That allows us then to get to the base bolt, so we can spin the head left and right. I was originally going to go for a 3-inch riser, but looking at it now, I think we're going to have to go for something a little bit bigger than that, because I'm thinking if I'm going to make something, I don't think 3 inches is going to be big enough, to be fair. So we're going to go for probably twice that, maybe 6, I suppose, with the 215mm plates. That's going to just take it to just over 7 inches. I think we'll still be all right for table travel. If not, we've always got the quill to rely on, and we'll see how we go from there. Not quite sure what I'm going to do first. I think the idea is I'll probably make up the plates, top and bottom, which we shall probably set up on the rotary table on the mill, centre the rotary table, then centre the plate, and then we can run a cut around it on the rotary table. That'll probably be quicker than trying to mess about on the lathe. We can also bore the hole. Probably not to finish dimension. Concentricity might be a bit of a problem because it's going to be a welded part. So I'm probably going to take everything somewhere near dimension, and then once it's all finished, we can set it up on the lathe and face it, turn it, bore it, and do what we've got to do. food for thought. Okay, here's our one of our plates anyway. It's currently a little bit too big, but it's almost size. So we want 195 diameter, so we're almost there. So we'll add a little bit of layout lines. Notice the obligatory T-ring. So let's go around about the 100 mark and in the centre, and that will allow us to add some layout lines so we can see what we're doing. So we'll give ourselves a little bit of room. We're coming just over 100. That should be more than enough. And then we want to find the centre, and we are at 200 at the moment. So if we go to the 100, which is there, and now we can dot punch that and get it set up on the rotary table and find the centre. Off to the mill we go. Right, so there we are. We've found the centre of the rotary table with the coaxial gauge, which just makes life so much easier. So we're within 0.01 of the centre. That's pretty close for what we want, considering this is going to be a welded part. I think that's definitely close enough. Right, we've got our plate mounted to the rotary table now. We've got it mounted on some parallels so that we don't obviously hit the rotary table. And we've got some clamps on there. So hopefully we take some very light cuts, take our time with it, and hopefully we'll get there. Right, well, after quite some machining, as you can see, we've got most of our components ready to go now. We've got the base plate is here, obviously the top plate there, and then our various components. These nicely bent pieces will form the scallop around the base nuts, so that will fit on there, get welded on with a little top hat to go on it, and that will sit there. And that will give us a hopefully enough room to get the spanner in to be able to slacken and tighten the nuts on the base in order to swivel the head. And then we're going to use these in vertical fashion all the way round in between, blah blah blah, to give us the height. And then we'll have to cut some down, hopefully 3, to get in the top of there and weld it all together. First off, we're going to weld these on because they're not that critical. So I think we're going to weld these on, and then after that we shall tack on probably 3 of the uprights, and then we'll set the whole thing up in the lathe with a some form of bung to locate the tailstock into there, hopefully to keep the concentricity, and then we'll work on getting it tacked together and then see where we go from there. Right, here we go then. It's all tacked up. So we filled in all the holes, leaving some nice big gaps to be able to weld up to. I did change my mind, in fairness. I ended up clamping it to the milling table, and then finding the centres. I managed to centre it up that way and hold it while I tacked everything in. Yes, I did protect the mill table, don't worry. So hopefully concentricity isn't going to be too bad. We won't know till we get it set up on the mill, on the lathe rather, but yes, we shall see. If the worst comes to the worst, it can always be bolted back to the mill table and then fly cut or something, just to make sure that the head is nice and level. Obviously we'll tram it in afterwards, but that's a little way off yet, so got a bit of welding to do. Shame it's not so cold today, isn't it really? There you go. Actually, strike that. I'll have a cup of tea first. Whew. Getting hot in here. Whew. Well, as you can see, we've got some really nice fillets going on there. We've really managed to fill up those gaps between the verticals. One thing that concerns me though is the gaps. There's very little gap, even though I've chamfered the edges. There's very little gap there, so by the time we machine this, it's not going to leave a great deal of weld. So I think what I'm going to do, I'm going to run a slitting disc all the way around, just to give us a bit more gap on both ends, and then we can fully weld it and start machining. Right, so as I mentioned, we've ran the grinder with a 3mm slitting disc. We've run the grinder through all the way round on the top and the bottom, and now it's fully welded. There's still quite a nice bit of heat in it, but I think once that cools down, we'll get it set up on the lathe and have a go. See where we go from there. Right, well here we are, all set up on the old girl. We've got that pretty close actually, to be fair. It doesn't look like it's going to be that far out, so hopefully there's plenty of material on it to take off. We've already run our scratch pass, which is just starting to catch there, so that's the highest point. So we're going to zero the DRO there, and some very nice light cuts, and make sure it stays in there, because if it comes out it's going to hurt. So let's see how we get on. Okay, so all the turning is finished. We're nice and cleaned up. Certainly good enough for a coat of paint anyway. Deburred, lovely, ready to go. So we've also faced off what we can reach on the front face while the concentricity is in place. That way, when we spin it, we've got a couple of areas that we can run a dial gauge over to make sure we're running true. So really the only last job we need to do is to finish off this internal bore on this end to make sure it's nice and true, obviously for when we spin it. We faced off this and done the register. So what we need to do now is we need to mark on a witness mark, excuse the noise, a witness mark for the PCD for the holes in the bottom, which we shall use the DRO for. Right, so in order for us to find our PCD, we need a known reference point. Luckily we have our register on the back here. So we're going to use the paper touch method of touching off. So we just put a piece of paper in there like that, and then we come in with the cutter until such times as it just grips the paper, and there we go. So we've just grabbed the paper, so that is definitely, yeah, that's definitely got it. Lovely. The thickness of the paper for our accuracy is going to make no difference whatsoever, so we can call that 0. But we have actually got a dimension, and I know that because I just measured it. So then we can program the DRO with that dimension and get us exactly where we want, like so. DRO now knows where the cutter is, but the lovely part with the DRO is we can actually tell it what size. So if we set the Y direction to a size of 114.78 and enter that in, the DRO now knows where the cutter is. So now we can index the cutter out to what the PCD that we want, which is 154.5. That will put the cutter exactly where we need it. Very clever. And now we're in the right place. It's a very simple case of just a little witness mark, and we can mark our PCD. Simple. So now we're just going to clean up this little bit of the face that we couldn't get to because of the tailstock support, so that will finish that off quite nicely. Right, and here we are all set up ready for the we're going to true up this bore now in the bottom end, so that when we're ready to spin it round, we know we've got still hopefully our concentricity. Right, so we're all spun round now. We got it set up really nice to within 2/100ths of a millimetre, which I think, considering what it is pretty good. We've finished off the facing of the top plate. And now we just need to take out the bore to the finished size 115. So we'll take a cleaning pass on that, and then we'll measure it. We'll do exactly as we did before with the DRO. We'll tell the DRO where we are, and then we can get pretty damn close. Right, there we go. That should be all the machining done. We just need some holes in the bottom, and that's good. Our bore is all done. Currently it's around about 1/2 millimetre too big. But that's obviously going to shrink because there's quite a bit of heat in it from machining. So we'll let that cool down. We'll give it a measure before I take it out the chuck. We'll give it a measure, see what we're at. If we need a bit more, we can always give it a bit more. And obviously you know what that means. Well, we've got it set up on the drill. I was going to drill it on the milling machine, but surprise surprise, there's not enough room. Typical. Who said confidence was overrated? I haven't even tried it yet. This is the only trouble with making a mess, clearing it up. And made a fine mess I have. Right, well, here it is, all finished off in its coat of dove grey. We just need to install the studs in the top with the lock nuts to lock them in. And get it installed. At last, and there it is, it's all fitted, tightened up. Lovely, look at that. Now we've got just over 10 inches between the vise and the chuck. Take the vise off, I could probably get an engine block on there. So, perfecto. It's been quite a challenge, I must admit, but it's done and I'm happy. So, DRO next, I suppose. Can't wait. Tune in next time, and see how we get on with that.